Hey there, Geometry. It's Mr. Lamb coming to you with page 2 of this quiz review. It says question number 6 and 7, and it looks like question 8 maybe. It says determine whether the polygons are similar. I guess this is just for number 6 and 7. Determine whether the polygons are similar. If so, write a similarity statement and give the scale factor. If not, explain. You may not use angle-angle, side-side-side, or side-angle-side similarity for this section. So I don't want to do the shortcuts. I actually just want to check, and remember we had talked about in section 2, we had talked about if we have similar triangles, all of the sides are proportional to one another. All of the sides are proportional. So let's take a look at number 6. I have a right triangle, but I don't know the hypotenuse. I know a leg is 8 and a leg is 12. So hopefully you remember the Pythagorean theorem, because a squared plus b squared equals c squared. So in this case, 8 squared plus 12 squared is 208. And the square root of 208 is not a real nice number. So I'm just going to leave that as the square root of 208. And on the other one, 3 squared is 9, plus 4 squared is 16. Add them together, it's 25. The square root of 25 is 5. And now I'm going to set up my proportion. So 3 sides, so 3 proportions. I'll go small side to big side. So looking at my left triangle, triangle QRS, the small side is 8, the middle side is 12, the big side is radical 208. On the triangle TUV, small side is 3, then 4, then 5. And this is pretty easy to see. 8 over 3 does not reduce. So that's still 8/3. 12 over 4 reduces to 3 over 1, and those two things are not the same. And oddly enough, if you try to simplify radical 208 over 5, that does not simplify either. So all 3 of those ratios are different. So that means these two things are not similar to one another. These two triangles are not similar. Even though they both have one right angle, they are not similar to one another. All right, number 7. Number 7, it gives me some angle measures. So I do know this. I know that the sum of the interior angles has to be equal to 180. So I'm going to start with triangle BCD. I'll do 180 minus 88 degrees minus 49 degrees to find that missing angle here is 43. And triangle IJH, you do 180 degrees minus 43 degrees minus 49 degrees, and you'll find that that H is 88. So the good news is all of the angles are the same. I have a 43, a 49, and an 88, 43, 49, 88 in both of them. So now I just need to check to make sure the sides are proportional. So again, 3 sides. Top of the left triangle, triangle BCD, small to large is 6, 9, 12. And triangle IHJ is 4, 6, and 8. So 4, 6, and 8. And when I go to simplify these, 6 over 4 reduces to 3 over 2. 9 over 6 reduces to 3 over 2. So those two are the same. And 12 over 8 reduces to, you guessed it, 3 over 2. So these two triangles are in fact similar. These things are similar. So it wants me to write the similarity statement. So the first triangle, I don't care how you name it, I will go, I don't know, BCD. So triangle BCD is similar to triangle. Now I have to look at it. So angle B was 88 degrees. So in the other triangle, angle H is 88 degrees. So it's H. Angle C was 43, and angle I is 43. And angle D was 49, and J is 49, so HIJ. Again, remember, if you named your first triangle something different, then obviously your second triangle will be named different as well. I'm looking to make sure that the corresponding parts do match up. So question number 7, this one does work out. The scale factor, for those of you wondering, is that number that they all had in common. When I reduce that, it reduces down to the scale factor. So the scale factor is 3 over 2, meaning that the triangle on the left, the one that I put on the top of all of my fractions, so triangle BCD has a 3 to 2 relationship to triangle IJH. It is bigger because 3 is bigger than 2. All right, let's jump down here to number 8. Number 8, these are some different directions. It says triangle ABC is similar to triangle FDE. And it wants us to find the value of x. So the first thing I'm going to do, I am going to just write out my ratio, my extended ratio. So my first triangle has sides AB, BC, and CA. And now I'll find the corresponding pair. So if it's AB, it has to be FB. BC has to be DE, and CA has to be EF. All right, now I'm going to plug in some numbers. So I want to kind of copy this thing down again underneath. I want to put in things that I know. I know this. I know that right there, that number 9. BC is 9, so it's going to go right there. What else do I know? I know that AC, so AC or CA is x plus 4.4. I know that EF is 23.5. So it goes in the position of EF. And I know that DE is 22.5. So I don't know anything about AB or FD, and you'll notice that you can see that they are blank over here. I don't know what those things are, and I don't need them. I only need 2 of the fractions anyhow. All right, so let's get a little algebra 1 going here. I'm going to do my 22.5, so I'm going to let me highlight this. I'm going to do this one first. All right, so 22.5 times x is 22.5x. And 22.5 times 4.4 is 99. And that is going to be equal to the other diagonal, 9 times 23.5, which is 211.5. Okay, I'm going to subtract 99 on both sides. So 22.5x is equal to 112.5. And then I'm going to divide by 22.5 on both sides. And I find that x is equal to 5. Now, it does not tell me to go back and find the length of any of the sides. It just says find the value of x, so I can be done there. Be careful on the quiz or any tests. Sometimes it will trick you. It'll say find the value of x and find the length of AC. And if that's the case, then you have to go plug 5 into that statement, x plus 4.4, and say that AC is 9.4. But it doesn't ask, so we can just move on. All right, number 9, determine whether the triangles are similar. If so, write a similarity statement and name the postulate or theorem you used. If not, explain. So, looking at number 9, I can see that I have bow tie triangles, so my vertical angles are congruent. I also see that side AB is parallel to CD, which means that alternate interior angles, so angle A is congruent to angle D. to question number 9. Are these two triangles similar? They absolutely are by the angle-angle similarity postulate. So it wants us to write a similarity statement. So here we go. Triangle, name it however you want. So I'll go ABE is similar to triangle. Angle A is the same as angle D. Angle B is the same as angle C. And angle E is the same as angle E. So triangle ABE is similar to triangle DCE. Number 10. All right, I have 90-degree angles, so I have an angle. You can see that angle V is the same as angle X. I do not know if I have sides that are proportional or not, so I'm just going to check that. I'm going to check for a proportion. I'll use this triangle first. Small side is 10, big side is 28. Okay, now let's look at the little baby triangle up in the top. Small side is 5, big side is 14, and let's simplify. 10 over 5 simplifies to 2 to 1. 28 over 14 simplifies to 2 to 1. So yes, it does have a scale factor of 2 to 1. So the sides are proportional, and the angle is congruent. So side, angle, side, similarity is the one that we'll be using here. Let's write a similarity statement. The big triangle down here in the lower left, I'll call it, I don't know, triangle TUV. It's similar to triangle. So angle T, and so that's going to be U. And then where the U is, that'll be W. And where the V is, that'll be X. You do have to be a little careful on this one. This one does look a little crazy because the U in triangle TUV and the U in triangle UWX, that U is not in the same location as a corresponding part. So you do have to be a little careful there when you're writing that statement. Again, how did I know that? Well, I knew that TV and UX need to be in the same spot. So you can see here is T, then V. So here is U, then X. All right. So that's kind of what I was looking at as I was writing that statement. All right, we made it to the last one, very last question of this review, and this is an indirect measurement question. So let's go this color. It says Thales was an ancient philosopher familiar with similar triangles. One story about him says that he found the height of a pyramid by measuring its shadow and his own shadow at the same time. If Thales was 5 feet tall, what was the height of the pyramid in the drawing? So think about this triangle over here. It says that he is 5 feet tall. That is a 90-degree angle right there. So I have a little triangle that's 5 by 6. This triangle on the inside, I'm going to highlight it so you can see it a little bit better. Has a base of 318 and a height of, I don't know. That's what I want to find. So these two triangles are similar to one another. Again, if you wonder why, it's because they both have a 90-degree angle, so that's one angle they have in common, and they get measured at the same time, so the angle that the sun is hitting them is at the same, so the shadow that is cast is coming from the same angle. So let's take a look at the left triangle. We'll do its height over its shadow. So height is H and its shadow, and I can put shadow over here on the top. Shadow is 318. And for the small triangle, the height is 5 and the shadow is 6. So again, I'm putting height over height and shadow over shadow. And now we just cross multiply one last time. So 6 times H is 6H. And 5 times 318 is 1,590. Divide by 6, and the height is 265. And this does take a measurement, and everything up here is measured in feet. So this measurement will also be feet. So the height of that pyramid will be approximately 265 feet. That does it for the quiz review. If you have any other questions, please let me know. Don't be afraid to email me or just ask in class. Have a great night, guys.